Hi everyone, welcome to my channel. I'm Alex. I'm a Google developer expert for Firebase, and I'm gonna show you in this video how to implement pagination in a real-time database using Jetpack Compose. This is a video for an article that I wrote. Link is in the description below, which was recently published on the Firebase tips and tricks publication on Medium. So let's begin. First of all, when we are dealing with a large amount of data, we know that you can't read it all at once. Why? Because it will take an enormous amount of time only to download it on the device. Besides that, if the data doesn't fit into the memory, it's possible to get an out of memory error. When it comes to user, I'm positive that nobody will ever be interested in reading such a huge amount of data. And from a billing perspective, everything in the real-time database is about how much bandwidth it consumes. So it won't be a good choice to read all the data that exists under a node. The best option that we have is to paginate the results. We have to load the data progressively in smaller chunks. In this video, I will try to explain how paging tree library works with the real-time database. I will use the MVVM architecture pattern with flow and ViewModel. For the asynchronous calls to real-time database, I will use Kotlin coroutine. For dependency injection, I will use Hilt, and for the UI, I will use Jetpack Compose. Now let's take a look at how this application looks like. Let's launch the application. And we have just displayed 10 items. We can scroll down. We can scroll even down, even to the last product in the list. We can also scroll up. And if you want, we can also open a particular product. Let's open sugar. To see the details of the product, we can hit back and we can continue to scroll from where we left. On the other hand, if you are interested in how to paginate Firestore, then I recommend you check the following article. To see how the paging tree library works with Jetpack Compose, we'll create a very simple application with only two screens. In one, we'll display some products that exist in the real-time database node, and in the other one, we'll display the details of the product. Because a product object can hold a lot of fields, we'll create two separate nodes in the database. The first one will contain key value pairs where the key is the product key and the value is the name of the product. These types of objects can be considered lightweight objects as they contain a very small amount of data. And the second one will be a node that will contain the heavy objects, basically the objects that will contain all the fields. What's the mechanism? When we launch the app, we'll query a node called product names and we'll display the product names in a lazy column. Each row is represented by a product object that has only two fields populated, the product key and the product name. Here is what it looks like in the database. When a user clicks on a particular product, we grab the product key and we create the reference that points exactly to the product object that contains all fields. Here is what the product node looks like in the database. And here is how a heavy object looks like. It's true that in real-world applications, such an object can contain a lot more fields that you can see, but I only used 11 to help you create an idea. Why we have the data in two different locations? Simply because we try to optimize the amount of data we download as much as we can. So we store lightweight objects in a node while the heavy objects are only downloaded on demand from the other node. This technique is called denormalization and it's a quite common practice when it comes to NoSQL databases as the real-time database. It's true that in such cases we have to maintain the nodes in sync. This means that each time a new product is added to the products node, it has to be added to the products num as well. The same when the product is deleted or updated. This also means that it applies a bit more work for the programmer, but it saves a lot of bandwidth for the project. So the easiest solution to make such a mechanism work will be to use cloud functions for Firebase. As you have seen in the database, each element within the node is a product object. So here is the corresponding data class. If you read some of my latest articles, you are probably already familiar with the fact that I'm a fan of MVVM architecture pattern. That being said, the code in this project is divided in 3 separate layers: the data layer, the domain layer, and the presentation layer. Now let's jump to the operation of reading the product names from the real-time database, which is defined inside the products repository interface. The implementation of this method is present inside the product repository implementation class, where we inject in the constructor a Firestore paging source and the paging config object in order to set up a pager and return a flow. Here we set up a stream of paging data. The pager class contains functions that expose the stream of paging data objects from the paging source. When we create a new instance of the pager class, it's mandatory to provide an object of type paging config to tell the pager how to load the data. In this example, I have added the creation of the objects inside the app module class. I have set an additional property called page size to 10, but there are also other properties like initial load size or prefetch distance. You can set all these properties exactly as you need in your project. Now all the magic regarding pagination happens inside the product paging source class, where we set up a stream of page items from the real-time database. This can also be called our network data source. Our intention is to propagate the query results, basically the product names, to the product screen. As you can see, this class includes a suspend load function, which is especially overridden to indicate how to retrieve the page data from the real-time database. So I created this class to directly use Kotlin coroutine for our asynchronous data loading. Please also note that the load param object that is received as an argument contains the result of the load operation. The load function returns an object of type load result, which is a seal class that takes the form of the load result page if the load is successful, or a load result error if the load fails. Going further to the presentation layer, inside it we can find a single activity called the main activity, where we create a nav controller instance that it passes to the nav graph of our project. In order to create a request to get the details of a particular product, we need to pass the product ID from one screen to another, and we do that using nav arguments. Now let's take a look at our product screen, where the content displays the paging items that are collected from the flow in a lazy column. Since the operation for getting the initial page or the next page might fail, it means that we have to handle errors when we refresh the data or when we append data. Besides that, we also need to know the loading state, so we can display a progress bar to the user while loading data. Here is also the ViewModel class where we get the paging items. As soon as the user clicks on a product, we perform another request to get the details of that particular product. Inside our domain layer, I have created another interface called product repository, where the abstract method has the following implementation. In order to make it work, I have added the creation of the following object inside the app module file. Back to the UI, the product screen looks as simple as this, where the content contains a column of product details. The ViewModel class where we get the data looks like this. When we launch the app, the progress bar is displayed twice. Since we load the data in chunks of 10 items, the progress bar is displayed for the first 10 items. Since all 10 items are visible on the screen, another call to Firestore is performed to get the next 10 items, hence the second display of the progress bar. Please note that I have implemented a nice feature, which is when we hit back, navigating from the product details screen back to the product screen, the position is maintained. It's really helpful because you can continue to scroll from where we left off last time. In conclusion, in this video we just seen how we can optimize the process of reading data from the real-time database. We have implemented pagination so we can load only 10 products at a time rather than downloading all of them. And we displayed the lightweight version of the objects rather than the entire objects themselves. That's the simple solution for implementing pagination in the real-time database using a clean architecture and Jetpack Compose. The new paging library is much easier to use and implement and works pretty well with the real-time database. So I hope you find this video useful, and if you have any questions regarding this topic, feel free and leave a comment in the section below. So in the end, guys, you can check the entire article on Medium. If you enjoyed the video, please hit the like button. But if you think you learned something new, please subscribe to my channel because more videos are coming. Bye!